fun stuff. Let's get the fucking TikTok running. Let's get the YouTube running. Everyone's got to know. Everyone's got to know they can get help right now. Every platform. I'm tempted to start streaming on Rumble. I think it would be hilarious.
Oh, Rumble? Oh,
yeah,
no.
Rumble. Yeah, right? I don't know.
No.
I don't know, dude. Even people on Rumble need math help, probably. Honestly, right? Yeah.
You might even rack up some views on that.
Right? Yeah. Maybe if I start doing like some like weird like conspiracy theory math, like I don't know. How many Jeffrey Epsteins does it take to like screw in a light bulb? Answer is none because he's dead. But he unalived himself, unfortunately. Or the government. Don't watch my stuff, government. Please don't do it. Right, 1 second. This green screen's also like messing with me. Okay. What's Rumble? Rumble's kind of like an alt-right, like 4chan of like video streaming. There's a lot of weird shit on Rumble. You can get away with a lot more.
Yeah, it's like how do you say it? A more open Twitch.
Yeah, you're allowed to be like racist. They don't give a shit.
Yeah.
I don't think anybody should be racist, but you're allowed to do more shit on Rumble for sure.
Yeah.
Okay, cool. All right, let's help you out, Nick, because you're here. When's your test, Nick? Coming up? What's up?
Tomorrow I won't be able to be with you.
Okay.
I won't be able to join.
You done messed up, Aaron!
Because I got a recertification for a job. So
Oh, nice.
go do
Recert.
that.
What's the job? What'd you get recerted for, dog? That's cool.
For the Board of Elections, remember that?
Oh, I don't remember that, but that's cool. Oh, are you going to help out with the midterms coming up?
No, the Board of Elections is in the voting stuff.
Oh, the voting shit. Okay, cool. All right,
Yeah.
one sec. Let me start. Oh, I need the chats to work. I apologize. Probably have no one on the chats right now. Let's activate these. Activate chat. Activate chat. There we go. Rotate this god-awful CAPTCHA. There we go. Nice, cool. There we go. Test. Yeah, that's working. Awesome. Let me make sure. Well, that's ChatGPT. I don't need that. I don't need this either, actually, honestly. Where is my other thing? Here it is. There we go. Okay, cool. And then, welcome. Odin says, what's good, Unc? I thought the stream was at 7. It would have been. I had to move it an hour early today because I have another student I have to tutor. And I wanted to make sure I could tutor you. I could work with you guys for 2 hours instead of just 1. So, here we are. Welcome. If you want to submit a question, Odin, I always like yours. Those are good too. Sib, you can also submit one too. Or do you want to just use the one you sent me last time? You can do that as well. Also, Nick, what's up with your fucking audio, dude? I hear myself.
Oh, you do? It's so bad. This phone is so bad. Let me
go get some headphones.
Switch.
Yeah,
let me switch the phones. Give me uno momento.
Un momento. Okay. While he waits, I'm gonna make sure all this stuff is going. Nice. The one from yesterday, cool. Let me make sure I still have it though, Sib. Unfortunately, well, not unfortunately, but like how I have this set up is that it does like reset the images I want to say every 48 hours, maybe every 24. Well, this person, who's me? Who's this? I have this question that got submitted. Whoever this is. You just submitted it 3 times. That is you. What's up, mad programmer? And then let me see. You can hear me? Yeah, okay. And then, oh, Sib, this was yours. Okay, cool. I think I still got it. You're okay, dude. You just had to mash the submit button a lot. I'm just curious if that's an error on my end or like a user error. Okay, and then Sib, this is yours, I'm pretty sure, from yesterday. Sweet. Okay, cool. That's yours. All right, we'll help Nick out first, and then I'll do a couple with Nick, and then we'll move forward. Kinzer, you say you need help. Kinzer, I'm more than happy to help you, Kinzer. Welcome to the stream. If you want to submit questions, so the best way, Kinzer, for us to help you, like help me help you, is to post a screenshot in this channel called Help Screenshots. You can also, if you don't want to like deal with Discord and stuff, you can just do it on your phone. and the website is here. That's submit.actualeducation. If you use that website, that's a very easy way to submit a screenshot, and then that's how I help you. Popolia says, I know what a segment ray is. Good, dope, dude.
That's dope. I'm
glad, dude. Okay, let's help with this. All right, Nick. A worked 5 days on overhauling an old car. B worked 4 days to finish the job. After the sale of the car, the net profit was $243. They wanted to divide the profit on the basis of the time spent by each. So now they want to know, how much profit did A take from it? Like, what's like their fair share? Okay. Do you know how to solve this? Do you have any idea how to solve this?
Noise. I'm still with the family.
What about the
four
family?
Children?
What about the 4
I'm
children?
still with family. Yeah.
Oh, okay, whatever. I'll go over it then. It's fine. Okay, so what we like, if we want to know what like somebody's share is, okay, somebody's share is always equal to like the part divided by the whole, is what we say, right? So, we know that person A, so let's say A's share, is they worked on it for 5 days, okay? But how many total days, like the whole, how many total days did they work on this car, like the both of them?
One worked 5, the other one worked 4.
Good. So I mean,
9?
so good, 9, yeah. So 9 total days. Okay. Think about it here. If A worked 4 days and B worked 4 days, then they worked the same amount, right? And that would have been just 4 over 8, which is a half. That makes sense, right? You should get an equal cut if you both work the same amount of time. But person A worked an additional day. Okay. So you just need to get what this is, which I think is like 0.5555 repeating. Or it's really just 0.5 repeating. And then you got to multiply this by what the net profit was for the whole car. So that's 243. So, okay. What we got to do is we got to pull out our calculator. Calculator, where are you at? There you are.
One of the kids put a lollipop in my pocket. I didn't even know it was there. I charged my pocket. It started making weird ass sounds.
Was it half eaten? Was it like a half eaten lollipop?
Thank God, no.
Oh jeez.
What a kill it was.
All right, cool. Answer is 135. Nice. That's easy. Oh, good, Odin. You submitted a question. Cool. We'll go over it. Jury. Yeah, you're correct. Exactly. Yeah. If you wanted to figure out how much person B did, right? Well, then you know that A and B have to both add up to 243. So person B would just be 243 minus this. That you'd get the amount that they got, which I agree is 108. Exactly, Paul. Yeah. Yep. Good. You guys are all smart. You're all a bunch of geniuses. I love it. Okay, nice. Good job.
I DM'd you back to the other picture. I think we went through 18, but not 19 and 20. 19 for me is really hard.
Okay, let's do 19. And then I'll move on. We do have quite a few questions actually coming up. And we got 50 people on YouTube. What's up? Love that. Love that, dude.
50? What the hell?
50 people on YouTube, dude. That's fucking dope, dude.
That's dope.
Yeah.
YouTube has been taking off a lot lately, especially with the school year starting, and I'm here for it. So it helps us help more people out. Okay. Popola says 35. Okay, you give us the live count. Give us the live count, Popola, as it happens. I just see like something on my whatever chat that like updates, whatever this is. Yeah, that little thing that's like what updates and tells me. Okay, assume that you borrowed $2,000 on November 1st, 1999, for the use of which you were required to pay a simple interest semi-annually. Because semi-annually, I think, means twice a year? Or is that like every other year? I always get confused with this. Has anyone ever, like, this is always kind of a bitch, right? So, like, bi-weekly can mean either, like, twice a week or every 2 weeks. Semi-annually means twice a year. Yeah, would that be biannually, technically, right? Or biennial is every 2 years. Oh, okay. All right, cool. All right, apparently that's what it is. Jury's already on it. It says 700 right out the gate. Let's see. Okay, 7% a year. By May 1st, 2005, you would have paid interest amounting to. Oh, okay. So, yeah, and biweekly is not the same as monthly. Yeah, it's not. Yeah, every 2 weeks is like, I don't know, it's all confusing stuff. I mean, okay, simple interest. So that's interesting. Wow, punny. This means it's not compounded, which means you don't owe money on the money that you owe, like on the interest that you owe. Simple interest means you just pay like a flat rate on the money owed, and you don't pay more money on the interest accrued that you owe. Yeah, exactly, Popo. Yeah. This is very simple. Yeah, if this was yeah. It's interesting they put this semi-annually, because I think this is kind of like a distractor, because if it was compound interest, then I do care how many times I have to pay, and I care how many times it compounds, because for that's like A is equal to A naught, and then I think it's 1 plus, I want to say R over N to the NT. I think this is the equation that you have to use.
Oh, God. What the hell? I think I learned this like a long time ago.
This is compound interest, is what this is.
Yeah.
Yeah.
During COVID, yeah, I didn't understand jack shit.
Yeah, no one understood jack shit during COVID. That's very unfortunate. Yeah, so this is 7%. Now, interesting, they say by May 1st, 2005. This is cool. So that means you have to pay it probably at the beginning of the year and then halfway through the year, right? So you have to pay in January and you have to pay in June, right?
What was confusing is it started on November.
Right.
So do you start paying from November or January?
No. So, the first payment would be May. Yeah, is it every 6 months then? Is that how this works? Yeah, I forgot. Yeah, you gotta look up the dates. Yeah, sorry. So, yeah, okay, so semi-annually means you pay every 6 months. Okay?
Mm-hmm.
So, this is actually
Do you pay on November 1st, or you pay the next 6 months?
No. You never pay right when you take the loan. You pay after the first billing cycle. So, November is like month 11, right? So that means that 6 months from that, 11 plus 6 would be technically 17, right? But 12 is December.
5?
So it's 5, exactly. Yeah, so this is month 5. This is May. And then how you see you use this plus 6, and then you get to the other 11.
Right.
Yeah, it is kind of like it's kind of like finance, I guess. This is like kind of a fucking tricky question, honestly. Okay, so whatever. So this is 1999. So if we wanted to like count out the number of these due for 2005, I'll just do it manually. It's okay. There we go. So this is like 2000.
I like how you wrote out 11 and 5. That
dude, I have to, dude. So... I don't bro, I didn't know I didn't know the number of the months until I was probably like in high school. I was seriously like special.
I still don't know. You can say 1 month, I'm like, what?
Yeah.
Then I have to think about it. I'm like, oh, okay.
Sometimes like it helps just to draw this out, you know, because you will fuck up the half. You are right, Poipola, that it's just 7.5. I want to like illustrate that, how that is though. You are right, totally right. I agree with that. Okay.
What happened?
So we'll show you where this comes from. Okay. So you borrow here, right? You borrow here.
Mm-hmm.
Okay. So you end up paying here, right? You pay here and you pay here. Okay. Right. You're paying 7% per year, which means you're paying 3.5% every half year. So this would be saying you're paying 3.5% of the $2,000, right?
Wait,
that
you don't
borrowed?
pay 7% on
No,
every
so
time?
No. You pay 7% per year. Okay?
Oh.
So
Bruh.
half of the year you pay half of that percent. So that's 3.5%. So this is going to be $70. I mean, yeah, 3.5% of 2,000 is just 2 times 3.5 and put a 0 on it or something. So you pay $70 here. That means you're going to pay another $70 here. You pay $70 here. So let's just count the amount of times you got to pay $70, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right? Because the last time you pay is in May. 6, 7. Right. It is easy. I know it is easy, but sometimes it's good to, like, people see equations and whatnot, and it doesn't make sense to them. But if we visualize it this way, purportedly, like, sometimes it makes more sense to people. So I know, believe me, like, yeah, this looks like absurd to do all this, but it's good to illustrate. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 payments of $70. Okay, which dividing by 2, right? Yeah, that's 6.5 years. So I don't think it's 5.5, dude. I think it's 6.5.
It's actually 5.5.
Yeah.
I don't know how though.
Well, we fucked up somewhere. Can I not count today? Yeah, this is how you do it, CJ.
You're right on the 1999. You only pay the once.
Yeah.
On that one, and then you pay the 2000, 2001, 2, 3, and 4 and 5. So that's 1, 2, 3, 4, 5 years, and then 0.5 for the 1999.
Yeah. But wait, I think I counted too many payments though.
But it says semi-annually. So
he says I went to May. Oh, you know what? I did go to May 2026. Sorry, I'm actually dumb. Sorry. This is November of 1999, but then this is 2000 of May. So this is 2000 of November. This is 2001 of May. Oh no, dude. Oh, I need some pain, dude. This is bad, dude. Oh, that's fucked up, dude.
When you draw it all out and you still can't.
I still fucked up, dude. Okay, this is 2005. Thank you.
Bro, thank God we have so many people watching. Oh,
thank you. Thank you, everyone on YouTube, for, like, my sanity. Yeah, it's all good. Okay, cool. All right, fine. Okay, so that's 11 payments, which is 5.5 years. So, yeah, you're totally right, Popoli. You could have just done 5.5 times 0.07 times 2,000. That would get you the correct answer. 7%, 5.5 years, 2,000. So, okay, cool. So, what would that end up being? That would be 2,000 times 0.07 times 5.5, which is 770. Nice. Okay, cool. Answer choice D. Love that. We're correct. Good job, guys. Everyone got that right. Nice. Yeah. Now do it for compound interest?
Oh, God.
No, we don't need to do that. Not today.
You want to do it?
I don't necessarily want to do it, no.
No, I actually want to learn how to do compound.
I mean, that's kind of tricky. Having to figure out all the years and stuff. I don't like that.
Yeah.
CJ says, I've never seen a live tutor. Welcome. It is me. I've been doing this for like 4 years.
Almost 5.
Yeah.
No, let's see if it... Oh, I don't have the freaking... I was going to do the followage. Log in.
No. Feel free. Yeah, we've been doing this since, like, kind of during the pandemic to help students out who, like, can't afford tutors. Or, like, don't want tutors. Because we make it, like, fun for you to, like, get tutored. You can win prizes and shit. I give out gift cards all the time for people asking questions. Okay. Cool. Let me see. Jamal has a question too. Odin has a question too. Kinzer, did you submit one to me, Kinzer? I have a couple questions here. One second. Let me just pull them all in. Anyone who hasn't asked a question before, I'll do yours first because it is your first time. CJ says, I've thought about tutoring for development. I know multiple stacks like desktop apps, games. That's dope. Yeah, start streaming, dude. I will warn you, it is a very slow grind. Again, I've been at this for a while, but it's only after a couple years of doing it you start to really like pick up any sort of traction. Nerds forever. Okay, Absolute Mad Programmer says, this is my first time, let's do mine. Okay, cool. Alright, is this yours, Mad Programmer? I think this is yours, yeah. 3 evenly matched chess players, A, B, and C are in a tournament. A plays B first, and then the winner plays C. The winner always plays against the waiting player until a player wins twice in a row, becoming the champion. Find the probability that A is the champion. What is the average number of games C plays, knowing that A is the champion? Okay, so I gotta draw this out. Probability stuff for me requires what we call probability trees and stuff. So let me try to get this for you. One second. Grab that. Cool. Oh boy, probability. Yeah, probability can sometimes really hurt. Yeah, I know, I get sad. Just because it's kind of a mind fuck to think about these things. Okay, let's just see. Okay, evenly matched. So this is the cool thing. So the probability of winning is always 50%. I like this. This is basically a coin toss. Right? So the probability of winning is always equal to 50%. Be nice to Nightbot, Nick. I don't know why it doesn't work. Okay, so let's see. A and B fight, and then the winner of that. Okay, so here's what can happen. So we know A plays B first. So then there are 2 outcomes, right? There's the outcome that A wins, and then there's the outcome that B... This is called a probability tree. So we're going to, kind of map out, the situations of what can happen. Yeah, exactly. Yeah, you can just use programming to just brute force this, but it's fun to see what the math is behind it. And then the winner plays C. Okay. So then, if A wins, now A plays C, and in this case, B. If B wins, B would play C. And then the winner always plays against the waiting player until a player wins twice in a row. Oh, wow. Oh, man, do I want to draw out all the probabilities for this? Okay, I think we have to. Okay. So this is the first game, right? So then the next game would be A playing C, and assuming that A wins, now we have it's over, right? Now A has won twice until a player wins twice in a row. Okay. Otherwise, you could have C that wins, and it's not over. Interesting. The winning player always plays against the waiting player. Okay, but the games happen sequentially. Okay, so if A wins, it's over. If C wins, C then plays B, right? Because B is waiting. We got a Christmas tree with the odds. Yeah, dude, seriously. Yeah. Okay, so if C wins, C plays B, and then there's another 2 possibilities that can happen, right? C can win, and then it's over, right? Because C has now won twice. Or B can win. Man, but now B plays A, which again can result in 2 things. So A can win. In this case, the game is over, right? Because now A won here, and now A also won here. Or you could have B can win, and the game's also over, right? Because now B won here and B won here. Oh, it has to be 2 consecutive wins? Oh, fuck. You're so right. Oh, dang. That's no fun. Okay, fine. Okay, well, whatever. In this case, it would be over. This makes it way harder. Yeah. Dude, this sucks now. What? Yeah, this could go on forever, right? There's like a limiting case here. You want me to decorate the Christmas tree too? Yeah. You want me to put like some baubles on it? I could do that. Yeah. Well, that's not really a bauble. There you go. Yeah. You want put like a little Christmas tree? Is that what you want? You want like Christmas tree stuff on it? Yeah, this can go on forever. Okay, so this has to be a limit then at some point. Because eventually, like, getting down here, dude, is such a low probability, right? Ugh. Okay, so someone gave me a question that yes, I would need programming for this. I would 100% because this is just infinite. I would just like run this enough times until it converged at something. Yeah. Okay, but let me see if I see a pattern real quick. Okay. You have a 5-unit formula. Can you construct an infinite series? Maybe. Let me see. Usually when I draw the tree, I then see like a pattern for it. Because then this is basically restarting here, if that makes sense, right? Once we get to here, we're basically right here, where A has 1, okay? And then the thing like repeats itself. It's recursive. Wouldn't it be 1/3 because they're all equal in skill? So, Matt Primary says where we can find the sum of the geometric series when it goes to infinite because the common ratio is less than 1. Sure. Like yeah, because that's 50%, right? Okay. Find the probability that A is a champion. Let's just calculate the ones that I know, right? So, A can win, A can win. So, in order for that to happen, that's 50% of 50%. So, I know it's at least... So, the probability of, like, A being the champ is at least equal to 0.5 squared. Right? I hope there's no draws. No. No. There's always a winner. Yeah, exactly, CJ, yeah. That's like the practical way, but I think there is like a math way to do it. Yeah, mad programmer, are you coding this for me? So, let's see. Either like this is like I would say for instance like A. Okay? That's what happens. The other way that A could be the champion would be right A, B, or C, A. Like, this is another way that it can win. Or it could also be B, A. Yeah, let's think. Oh, B per C game means that A doesn't play. Yeah. Yeah, okay. No, this is cool. I mean, I like the hands-on of it. I see. Okay. So, if A wins, and then B wins, then A doesn't play, right? So then this is moot, right? This is like B or C. I don't care what happens here, right? Whatever. I could just actually, you know what I'm gonna do it as? I'm gonna do it as A and like not A, right? Because I don't care whether B or C are playing. Oh, unless like B or C gets the double first. Oh fuck. Oh. Can I show the question again? Yeah, sure. I'll show it to you. All right, I'm a couple minutes away from just ChatGPTing this. I understand like the structure of it, but in the effort of helping as many people as I can on this stream, sometimes when I reach a certain point, I'm just like, whatever, we're just gonna chat it. Well. Yeah, their score basically gets reset when they lose, correct. So, yeah, the second they lose, they have to go through another, like, series of this happening. Correct. So, okay, let's say that, like, let's say that B wins, okay, which means B needs to play again, right? So this happens automatically, right? And then you need A to win, and you need A to win, right? And actually, this could be B or C. So I don't think this doesn't count as part of the probability, right? This is 0.5 chance for this to happen. There's 100% chance that B or C wins. I don't care about that, right? So that's times 1. And then you have another 0.5 squared, right? Correct. If it's BB, then B... Oh, shit. You're right, actually. Oh. Okay. No, valid point. Okay. So then I need C to win. So this has to be... Okay, I like this. This is cool. I'm starting to maybe see a pattern. So this has to be BCAA. Oh. Odin Root, where are you, dude, with the gains, dude? We got the BCAAs in here, dude. Okay, so 0.5, 0.5, and then 0.5, 0.5. Okay. So, what is that? That's 25% already, plus this really, really small number. A quarter of a quarter, which is like 0.05. Okay, I will show the question one more time. Yeah, there you go. Screenshot it right now. I'm plugging this in the chat. I know it's at least like probably 30%. But if A won before B, wouldn't it be B followed by A? No. B is followed by B versus C, and I need C to win in order for B not to win twice in a row. And then it restarts the chain of A has to win, A has to win. Oh, if C won before B. Yeah, but the first match is always A versus B. That's what it says. It says the A always plays B first. Yeah, it says Markov processes. Yeah, it's okay. It's all right. This happens. This is totally cool. I appreciate this question, programmer. Thank you. But for everyone else watching who's in like high school or even college, don't worry about this. Like, if you don't understand this, don't think you're dumb or anything, because this is a pretty difficult, tricky question. I like tricky questions. I don't shy away from these. They're fun. But don't be upset if you don't get this, because I don't get this already. And I have a PhD in physics, so it just goes to show, like, knowledge is specialized sometimes. If I had my PhD in statistics, I would probably understand how to do this real quick. I also never touched Markov chains in my, like, academic career. Top 100 reasons to not learn probability. Okay, let's plug this in the chat. Let's just see what happens. Curious. Let's put on like the thinking meanie. Yo, what's up, Ace? Haven't seen you in a hot second, dude. What's going on, dude? How's life? Solve this. Let's see what. Continuing the chess puzzle, breaking down possible outcomes. It's doing a bunch of stuff. Setting up the equations. Also, programmer, do you know what the correct answer to this one is? I would love to know if ChatGPT is getting it right. Ace, are you in college yet? I forget, dude. You've been in my server for a while. Right? Let me see. I can see on your mod view how long you've been here. Yeah, you've been here since... Oh, 2024. I still think that's pretty long. It's almost a year. Oh, is there something up with my voice? Tell me. I think my voice is fine. Is it just higher pitched than normal? I sound fine here. Okay, cool. Alright. Maybe it's just Discord's fucked. CJ says, I just wrote a Python script. He got 5 out of 12. Mad Programmer says it's 5/14. Okay. ChatGPT's taking a while on this, actually. Dog, what? Come on. Solving a linear system using Gaussian elimination? I don't think it's a linear system. Yo, what? You gave me a question that broke ChatGPT. Chill. Okay, wait, there we go. All right, it says, nice puzzle, fun one. I'll do a small Markov state setup. The clanker is clanking, yeah. Well, let's see, does it get the right answer? It says 5/14. So it did do that correctly. Okay, here we go. All right. Label a state XY. X is the current winner, which has 1 consecutive win, and we'll play Y next. So the next match is QXY. Be the probability that A would eventually become Okay, let QXY be the probability that A eventually becomes the champion from state XY. From any state XY, the next match is X versus Y, with the probability of 1/2 X wins, and then X has 2 wins in a row, with probability 1/2 Y wins when we move to state YZ, where Z is the third player. Thus spoke. Okay. So it's 1/2. I don't understand this. What is this? Dude, yeah, wait, excuse me? What? Ask it to show a state transition diagram. Yeah, they have to be consecutive. Okay. I don't understand this notation, to be honest. Ladies and gentlemen, I don't know what this is. Write 6 equations for the 6 ordered pairs and solve. Symmetry shortens the work. So the probability of A and B being the next choice, which is equal to the probability of A and C being the next choice. Okay, I kind of agree with that. Is 4 out of 7. And I just like forgot to do this. Show your work, ChatGPT. Oh, they have a better explanation on you want to send me the link, Mad Programmer? Because I don't know if I'm understanding this. Oh, QBC equals QCB equals 1/7. Yeah, send us the link. I'll go through it. I don't know if I understand this. I never took anything involving like Markov chains. Yeah, give me a second. All right, you're cool. All right, we'll wait. Hold, please. Nice. Okay, there it is. Stack exchange. Okay. Do more math. We are doing math. This is probability, dog. Okay. Ooh, tennis players. Okay, cool. Here we go. So, clearly A and B have the same chance of winning. C has whatever probability remains, so let's look at A. There are unique sequences for A to win in rounds 2, 4, 5, 7. Oh, it's okay. So yeah, right, we said this. AA. We said BCAA. Oh, what's up, Poison Mouse? Okay, ACBAA. BCA, BCAA. AC. I keep thinking they're saying like all cops are bastards or something, dude. What's going on here? So the probability that A wins in the round is a fourth plus a 32nd plus 1 over 256. Okay, so I think we see a trend here, right? Similarly, the probability that he wins in round 4 and round 7 and... Oh, so these are geometrics. Yeah, I do definitely do hex. It says 4 out of 14. Oh, wait. No. Sorry, 5 out of 14. You're right. Okay. So, I think he's just noticing a pattern here. Yeah, hex is great, dude. Practice safe hex. Okay. Yeah, fuck ChatGPT. That didn't really make much sense to me, the ChatGPT. Oh, they have a better answer? Sorry. Well, I kind of liked that one. You like this one? You like the approved one? If he loses 2 games in a row are won by the same player and the tournament is over. Define P's the chance a player will win the tournament when he gets a new opportunity to. If he loses 2 games in a row are won by the same player. So, this is the one you used? If he wins twice, he wins the tournament. Right, okay. If he wins first, loses his next game, then he'll have to hope for a new opportunity. And the chances for that to happen, oh, very cool, is that the player he lost to will not win the next game. Okay, cool. Oh, okay. Oh, this is genius. CJ says, weird note, I made an analog to binary converter in Minecraft once. Yeah, I've seen the Minecraft calculators. They're super cool. Okay, since player C's first game is already against another game's victor, P is also the chance that C will win the tournament. For player A and B both equally likely, oh, then it's 1 minus P over 2. Very cool. Okay, I like this. I do grade 11. Yeah, submit a screenshot if you want me to go over it. I'll do it on the stream here. Okay. I like this explanation. I think it's very cool. I think it's much better than the ChatGPT one. Where are we? Yeah, up here. Okay. Which, I mean, we kind of had it. We had the AA, the BCAA, but yeah, I like this. This is a cool explanation. Yeah, also, feel free, like, join our Discord. So if you go to the actual discord.com/submit, that website there, it has our Discord, and you're more than welcome. Yeah, you can join here. You can also watch we have a schedule, like, how often we stream. So this is, like, today's stream, but we have another one tomorrow as well. And there are other friends that do math streams on Twitch, so go check those out. But yeah, feel free to join the Discord as well. If you guys want to still keep in touch. We have a pretty fun community of like 1,800 people. Okay, but yeah, so let me like try to describe this. So, we need him to win twice, right? Which means he needs to do a half times a half, which is equal to a quarter, right? That's the probability of winning twice. Now, if he doesn't win, right, on the first one, then he needs to hope that the next the person that beat him doesn't win again. Okay, so the probability of him getting another chance is that he wins, he loses, and then the other guy doesn't win again, right? I like this, PWLX. So yeah, this is like wins, he loses, but then the winner from here doesn't win again. Cool, which is an 8th. Because once that happens, he gets to restart. Then he gets to do this again. Okay? So he can either just win outright. That's a quarter chance. Or he could lose once and then try to get another chance and then win. That's a quarter. Or he could lose. Let me think. He could get another chance twice, and then he could win. Right, okay. And now this is a geometric series, right? This is the sum from n equals 0 to infinity of 1/4 times 1/8 to the n, right? Do you see how this, like, just the 8th power just keeps going up and up? And so that's a geometric series, which we know is equal to 1/4, and then it's 1 over 1 minus r. Oh, thanks, commenter. I appreciate it. So, right, cool. That's 2/7. If whatever, if I do the math there. Okay. So, that's 4 over 14. I'm curious why it ends up being 5 of 14. Since player C's game is already against another game's victor, P is also the chance that player C will win the tournament. Oh, I see. Because A and B are fighting, right? And so you don't care what happens to A or B. You don't care either way. But player C then now gets their first shot. Yeah. Yes, exactly. This is the series really of player C winning, because this is what happens. Because I don't care what happens here, right? Probably that's the probability of A and B playing each other is 1. I see. Okay. So P of C is equal to 4 over 14. And then we say that A and B have an equal chance of winning, and somebody has to win the tournament, right? So P of C plus P of A plus P of B, which is really just equal to 4 over 14 plus 2 times X, has to equal 14 over 14. Okay, very cool. So then, yeah, X is equal to 5 over 14, and that's a probability that A wins. Okay, cool. Very cool. I like that. That's a cool question. Thank you, programmer.
Yeah.
Same question, but add player D? God damn it. No, dude. Okay. Nice. Cool question, programmer. That was nice. I appreciated it. What's up? Yeah, you're the UK. Nice. Yeah, I do have a lot of people from the UK. My mother was technically born in Cambridge. I have a British passport. For reals. I got it, like, last year or something, just in case, like, shit really goes south in the US. But, yeah, I'm based in Los Angeles. How to solve geometric series? There's an equation for it. I can show it later at some point, but let me move on to another person's question, because that took a little bit of time. The UK kind of sucks too, though. Yeah, it's unfortunate. I really need my Italian passport, which my mother has an Italian passport. I should be able to get an Italian one as well. I'm not sure if Italy is really that much of a better place, but at least they got, like, good spaghetti. Don't visit here. It's no better than the US right now. Oh, damn. What, Mr. Starmer's fucking things up? Is that how things working? Okay. Whose question was this? From... I think we had... this is physics, and I do like physics. I know this is conservation of momentum. I want to know whose question this is, though. Let me see who submitted this. Starmer and Robinson and Musk. This is really math with the vectors. Oh, this came from Jamal. Jamal, are you still on the stream here? If you still are, I'll do your question, like, right away. I hate Markov. He will die again. What? I think physics is the harder subject. Okay. We'll do this one. And then Odin, I'll do yours, and then Sibley, I'll go into some math. Jeff loves math. Some vector calc. Physics, no chance. All right, let's see this. 6 kilogram object A. So 6 kilogram A is moving at 3 meters per second. Jeff likes Jeff, no math. Yeah. Collides with a stationary object B that's 5 kilograms. Physicists admire computer scientists and mathematicians. Dude, that's some strong words there. You know there's a hierarchy of the sciences, right? You want me to show the hierarchy of the sciences? Everyone does admire the mathematicians. Yeah, here it is. Yeah, this is it. Dude, I don't agree that astronomy is above physics, though. That's kind of sus, dude. What? I think astronomy should be below physics. Unless we're talking about, like, cosmology or something. Okay. Meters per second is what M sub S means. Sociology isn't even a real science. Okay. So this is before. And then after, A moves off at an angle 40 degrees left of its original direction. Okay, so A is now moving this way, 40 degrees. And B moves 50 degrees to the right. Okay. I think this is a fairly simple question to do. Yeah, comp sci used to not be a science, by the way. Yeah, it took a while for computer science to actually get accepted by the whatever powers that be scientific community as a science. They used to think it was just a bunch of nerds playing with, like, chips and shit. It definitely is a science. I think it's heavily rooted in math. Unless you get into, like, computer engineering, and then that probably is a little bit of physics. The magnitude of momentum of A after the collision is... Okay. So I'm going to call this, like, situation 1. I'll call this situation 2. When you were growing up, CS was just math. Yeah, that makes sense. Okay. Let's do the total momentum in both cases. We don't know if this is... Well, it's definitely not an inelastic collision, but I don't know if it's perfectly elastic. So I can't do anything about conservation of energy. But conservation of momentum I can do. Okay. So total momentum here is going to be... So momentum P is equal to M times V. The mass times the velocity of all the objects in the system. So in this system, the 6 kilogram mass is moving at a speed of 3. So I have 6 times 3. But then this thing is stationary. So that's going to be plus 5 times 0. Great. Awesome. Cool. Gravy. And also, this is all in the X direction. So when doing conservation momentum, you need to be careful in considering what the momentums are in each direction. In this case, we're going to deal with, like, left-right stuff as X, and then up-down stuff as being Y. Here, none of these things are moving up or down, so the Y momentum is equal to 0. Okay. And so then this is equal to 18 kilogram meters per second. I'm just gonna ignore the units for now. Don't be mad at me. Okay, afterwards, cool stuff here. So this is gonna have some. We're gonna call this, like, VA2. So that means velocity of the A thing in situation 2, and I'm gonna call this, like, VB2. Okay. If we look in the X direction, this mass is moving diagonally. And if it's moving diagonally, it means it has a component of its velocity, which is its momentum, in the X direction, and it also has a momentum in the Y direction. Well, momentum being negative would mean it's moving the opposite direction. But we know things are still moving to the right here. Okay, so afterwards, I need to consider, I would say, the 5 kilogram mass times VA2, but the X component of that. This is where trig comes in handy, right? This is why we learned trig in whatever 7th grade or something. I know everyone hates sine and cosine.
You done messed up, Aaron!
The reason why it's useful is because this makes a right triangle, where if this is the hypotenuse, right, then this right here is the adjacent. And so if I want this component of the triangle, I know that cosine of 40 degrees is equal to adjacent over hypotenuse. So that's going to equal to the hypotenuse, which is the total velocity of it, so VA2, divided by the adjacent. And the adjacent in this triangle, that is the x component, the amount of velocity in the x direction for this thing. So that's VA2x. Wait, I fucked this up. Sorry. Adjacent is VA2x. Hypotenuse is VA2. Almost made a mistake. Okay, there you go. Cool. Yeah, we always have trig. So adjacent, sorry, is this. That's VA2x. Yeah, it's easy trig. Yeah, don't worry about it. And then the hypotenuse is this, VA2. Okay, so then VA2x is the same thing as taking this and just like multiplying it over here. So we're going to say, instead of saying VA2x, I'm going to see VA2 cosine 40. So VA2 cosine 40 degrees. And then by the same token, the amount in the y direct, the amount in the x direction for the B box. That's velocity. And then mass times it will give me momentum. I also screwed this up because the first one is 6. It's not 5. Yeah. Yep. Thank you. So then this is 5, and then this is going to be VB2 cosine of 50 degrees. Cool. Dope. All right, and then in the y direction, now instead of cosine, we do sine. So cosine gets us the adjacent, which is like this part of the triangle. So if I want the y part, that's the opposite. And the trig function with opposite in it is sine. So this is going to be 6 VA2 sine 40 degrees plus, and then this is going to be 5 VB2 sine of 50 degrees. Okay, cool. And now, we might need tangent. I'm going to show you in a second here. So what I know is that for conservation of momentum, the momentum needs to be the same before and after in each individual direction. So in the x direction, this total needs to equal this total. So that tells me right away that 18 is equal to all this, is equal to the x component stuff. It then also tells me that 0, because there's no movement in the y direction here, there's no momentum in the y direction here, needs to equal the sum of the momentums in the y direction here. So that's this. So then we get 0 is equal to that. Okay. And I think what they want us to solve for is the magnitude of momentum. The magnitude of the momentum of A after the collision. So they want this. Which, cool. I think I just need to solve for VA2 and then, like, plug it back in. I don't know if there's an easy way to do this. Right? Yeah, magnitude of momentum is in both directions. Yeah, there's momentum. Yeah, momentum has 2 different directions, Jeff. I mean, luckily, like, from a math perspective, we know we're safe because I have 2 unknowns, right? VA2 and VB2, and I have 2 equations. So this is technically solvable. Assuming that they're not, you know, linearly dependent functions or something, right? Sum of square rooted. I feel like, man, what do I want to do here? How do I solve this? I could brute force this. Right? I could get an expression for what VB2 is in terms of VA2 and then just plug that into here. I think that is what I'm going to do. It's not a stupid idea. If this was a number, No, the problem is like the angles are different too. Ugh. Okay, whatever. Okay. I'm gonna solve this for VB2. Okay. So I'm gonna say that unless anyone sees like a quicker way to do this, I don't really see one. So this is gonna be -6/5 VA2 sine 40 degrees over the sine of 50 degrees. Oh, sine of 40 is cosine of 50. That might help. We'll see. You are right. That is true. Okay, so then if I plug that into here, we'll get something new. So now I'll get like 18. Or let me use different colors. So I'm gonna use the orange. So I get 18 is equal to 6 VA2 cosine 40 degrees plus 5 times I'm gonna say 5 cosine of 50 degrees. Right, cosine of 50 degrees that, and then we're gonna replace VB2. Yeah. Yeah, this is -6 because you move this over to the 0 side, you have to subtract, and then you have to divide by 5. And then there's this. Yeah, you got it? Cool. So there are some nice things here. So, this will cancel with this. I can then divide everything by 6, right? To pull this to be 3. So this goes away, this now becomes 3. And then let's see if Jeff's observation... No, right, you said cosine of 50 is the same as sine of 40. So that doesn't really help me out. I guess I get like cosine times cotangent maybe. But no, it doesn't really help me out, does it? Okay, so 3 is equal to... I'm going to pull the VA2 out. So I'm going to say VA2, and then that's going to be times cosine... Exactly, organized, right? Cosine of 40 degrees plus... Well, plus minus. So this is minus cosine of 50 degrees sine of 40 degrees all over the sine of 50 degrees. Okay. Cool. So then I just need to figure out like what this is. Selena says, I have a question. How can 2 blocks hit each other head on and suddenly gain up-down velocity instead of just exchanging momentum in the x-axis? Where does the direction of change come from? Cool. Maybe just from like the shape at which they are, right? I mean, let's pretend that like the shape of this thing was like a cone. Right? Let's pretend it was like this, right? Then it would like slide underneath this thing, right? And then that would rocket one way and one would start going the other direction. It has to do with the geometry of the collision. You're right. If it was 2 symmetric like cubes hitting each other, they should not gain any sort of components in the y direction. I think it's the shape. Okay, but let's pull up the calculator. No, it's cool. It's a good question, actually. It's good to be curious. Let me make sure I'm in degree mode. I know it's the inferior mode, but whatever. Cosine 40 minus cosine 50 sine 40 divided by sine 50. We're not doing easy momentum. This is a 2-dimensional question. Okay. Uh-oh. I fucked up. What did I do? Oh, I can't put the extra thing there? No, it should be okay. Okay, cosine 40 minus cosine 50. Yeah, cool. All right, awesome. So that's what that is. So then I do 3 divided by that. And that gets me 13.23 for VA2. Okay, so VA2 is equal to 13.23 23 meters per second. That's actually quite large. Okay, and then I just need to plug that into here to get the, yeah, to get the... That seems odd, though, bro. Wait, something's moving at 3 meters per second and suddenly starts moving at 13? How? I don't like this already. One sec. This is a good thing in physics to do, by the way. You should always, like, kinetic energy violation. Yeah, you should always check to make sure what you're doing seems plausible, right? This doesn't seem plausible to me. Yeah, we found an infinite money machine, basically. Let's double check, please. Let me just double check. 635018, cool. 6a cosine 40 plus 5b cosine 50. Cool. And then from this, 6a sine 40. I didn't call your name yet. No, you're okay. Oh, you know what it is? Here's the fuck up. Sorry. This is subtracted. See, this is a good example. I make mistakes. Like, we needed this to be negative because this one is going down. Okay. Aha. Excellent. Okay, good. Well, luckily that's an easy fix because this is just a positive. So then this is just a positive. So then this is just a positive. Nice. Yeah, no infinite energy. Sorry, Popo. Knowledge. Are you talking about, what's his name? Ty Lopez? The guy who has all the Lamborghinis. All the books in his garage with his Lamborghini. He used to say it all the time. He'd be like, knowledge. I actually tutored him way back. Probably 2015, I think. It was hilarious. Okay, this seems much more reasonable. 2.3. This is 2.3 meters per second. Nice. That seems way more reasonable. 13, I was like, no. That does not seem right, dude.
Oh, God!
Yeah, it can't be 13. Okay. So let's plug that into here. So 2.3, because they want the momentum of A after the collision. Oh, interesting. We don't plug that specifically into a direction then. That's the total momentum. So P of A2, like the total, is equal to M times VA2. The total velocity. I don't need the components of that. So that's just 6 times the 2.3. Which should be, what is that, like 19.8? No, I fucked that up. Sorry, 13.8. Yeah, 13.8. Cool, 13.8, I would say kilograms meters per second. Nice. I think that's right. I always like to double check my work because the student who asked this question is not here. But, so let's go send this to ChatGPT real quick. Let's put it on the fast one, instant. Let's just see if it can solve it instantly. Oh, it's doing it pretty well. Okay, cool. If I get the same answer, then I know I'm right. Blah, 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 blah. Okay. So it thinks it's 79. Okay, so ChatGPT probably screwed up. Can't use the instant one. Say try it again. I got 13.8. We'll let it think a little bit more. Because, bro, there's no way this thing gains momentum. Like, ChatGPT was wrong from the get-go. There's no way this thing can, like, gain momentum. Nice, you were right. I know I was right, ChatGPT. Okay, cool. 13.8 says it's correct. Love it. Good job, everybody.
Come on! Yes! Come on! Yes!
Nice. Sick. stub. Okay. Odin Root, then Sib. If anyone else has questions, again, feel free. Drop them in. We have a website for if you want to get free tutoring, you want to, whatever. You just have like something that confuses you in math or science. We'll do it here live on the stream. You just got to go to that website, which is www.actualdiscord.com/submit, and put in your username, attach a file, hit upload, and we'll get it. Also, feel free to go to this website so you can find out where we are on Twitch. If you're on YouTube, or we're streaming on TikTok too. I should put the TikTok here as well, actually. And then if you're on Twitch, you can visit us on YouTube. You can also join our Discord if you want to get more announcements for when we do this. We do all sorts of fun, like gaming stuff and learning and math and shit. And then here's our schedule. If you want to figure out the next time we're streaming. So we're on right now for the next probably 30 minutes. Tomorrow we'll be on again an hour later. So come on by. Odin Root, let's do yours. Yes, I definitely do AP Physics C. Both of those are totally valid. If you want to actually, I can actually show you something. What was it? If you go to my YouTube channel, I actually did a review session for AP Physics last year, or this year, I think. Let me think. AP Physics. Wait a second, let's just figure out what it is. Did I do it for C? Oh, I did it for AP Physics 1 this year, but I can do C as well. Yeah, so I do like live stream reviews before the AP exams where I'll just go through like, this was me going through like previous questions on the exams. So yeah, I can totally help you out with AP Physics C too if you want. Just drop a screenshot. All right, let's see Odin Roots. Write in standard form, identifying graph, the quadratic surface given by this. That is ugly. I'm assuming we need to, like, complete the square or something, right? So let's see. Also, I don't really want to graph this, dude. What? Z squared plus 4z, and then I say plus 2y squared plus 12y, and then minus x squared. So I can put the minus x squared here. And then we say is, like, equal to 23. My gut instinct here is to complete the square for each of these to kind of get it in, like, almost like, I would say vertex form, but it's like vertex form in 3 dimensions. Maybe I'm wrong, but the way to always complete the square is you take this, you divide it by 2, so that gets you 2, and then you square it, and then you add that, and you subtract that. So what you effectively did here is you added 0, which is okay, because adding 0 doesn't change the equation. But what that gives us is the opportunity to group these two things as now just z plus 2 squared. And then there's still a minus 4 out here. But that's okay. I can do the same thing here. I'm going to pull a 2 out first. So I'm going to say 2y squared plus 6y. And then I'm going to do the same completing the square thing. So I'm going to divide by 2. That's going to get me 3. I'm going to square it. I'm going to add 3 squared. I'm going to subtract 3 squared. And then I'm going to take this whole thing here and turn that into 2 times y plus 3 squared. Okay. But then there's still a minus 3 squared, which is still being times 2. So that's minus 2 times 3 squared. And this is all equal to 23. I think this is, I want to say this is linear algebra. It is going to look like an ellipsoid. It's actually pretty cool how this will work. Okay, so here's what we got. We got minus x squared. I'm going to say plus z plus 2 squared, right? But I think the minus fucks with things, Jeff. I think this would need to be plus for it to also be an ellipsoid. And then plus 2y plus 3 squared. And then I'm going to move all these things over. So I'm going to add the 4 over to 23. That's going to be 27. And then I'm going to add over the 2 times 9. So add over 18. So that's going to be 45. Yeah, I think I'm right? Yeah, this fucks it up. It's really annoying. Yeah, if this was a plus x squared, this would be beautiful. This would just be like x minus I squared plus y minus j squared plus z minus k squared is equal to r squared, where this would be a sphere. The second you have like one of these coefficients being different, which you would end up getting like a half, and like 1. Now this is kind of a distorted sphere. It's like an egg. Yeah, the coefficient messes it up. But I think the minus sign really messes it up. Okay. So when this happens, yeah, identify the quadratic surface. I don't know what this is. Like what? I like to do what I call like slices. So if I hold like one variable at the origin, like x equals 0, y equals 0, or z equals 0, then I can kind of see like what a cross section of this thing looks like. So let's say, for instance, yeah, level curves, right? Slices. Let's say I'm gonna hold y is equal to 0. Okay. Or really what I need to do is y is equal to -3, right? Yeah, because I want this whole term to go away. If y equals -3, the whole thing goes down, right? And now we're just left with negative x squared plus z plus 2 squared is equal to 45, which this is a hyperbole, no? Z minus 2 squared minus x squared is equal to 45. A paraboloid, yeah. Yeah, when they subtract... What is that shape? Conic sections. Might be easier to hold x constant because then you get all circles. I agree. Yeah, I need... Where are the equations for these things? That's in standard form. I want them in... Yeah, this is the form I want. Yeah. Yeah, I think this is what I want. So... And I think it's like whichever one's bigger. Is that right? Like A is always bigger than B? Or no? Actually, it doesn't matter. This just tells me the amount of like curvature to it. Okay, so Z minus X means it's transverse to the Z-axis. No, sorry, it's the transverse axis is parallel to the Z-axis. And I guess this is the transverse axis, right? So that tells me also we're down by a factor of 2. So out here at -3, I have like kind of like this, right? That comes from this. Okay. What's the highest level of math you've done? Complex analysis. Yeah, that's probably the highest math. I'm very good at calculus. Very good at vector calc. I'm decent at diffie-q. I like linear algebra. Complex analysis, I technically know, but I don't really teach it very often. It doesn't get asked very much on the internet. Okay, so that's at y equals -3. Okay, if we then do things at, and here, let me make this all the same color so we can kind of see like what's going on. So this was y was equal to -3. We could also do things at x equals 0, right? At x equals 0, now you get z plus 2 squared over 2 plus y plus 3 squared over 1 is equal to 45 over 2. Sure, Everett. Do you have an example question of a proof that you're going through? Is it a geometry proof? It would help if I knew, Everett, like what level of math you're in, and the best way for me to figure that out is to see a screenshot of like a similar question you're working on. I can very quickly tell what level of math you're in if I can just see what a question is that you're working on. Because I've seen everything at this point. Cool. Yeah, get your notebook. Yeah, take a picture of it, and then use that website down there and just send me the screenshot. And then I can explain it to you. Okay, so this is an ellipse, which is... I want to say it's longer in the z-axis, right? So at x equals 0. So at x equals 0, in the zy axis, you have an ellipse, which is located 2 down, and to the left 3. Oh, look, this comes up again, right? So this is the center, and then it looks something like... Jeff, I think this means it's the major axis in the z direction is bigger. Is that right? So I want to say it's like this. I think. Yeah, I'm trying to remember, right? This is why you got to remember your conic sections. I know you guys hate it in like pre-calculate. Why are we learning conic sections? Because it does come up. Okay. So it's a weird ass shape already. The last thing is to hold z constant somewhere. So you could do like z is equal to -2, and then you would get another paraboloid, right? Because now you would get y plus 3 squared minus x squared over 2 is equal to 45 over 2. And now this is something that is parallel to the y-axis, located 3 okay, so this looks, and then what does that say? Yeah, but then it's centered at x equals 0, so I think it looks like this. Yeah. Okay. I don't know what to call this shape. A saddle? It's kind of like a saddle. Cheat sheet and use Desmos? Sure. Fine. Well, let's see if we got it right for the standard form real quick. I'm going to ask chat to put it in the standard form. Just make sure we got that right. I'm pretty sure we got that right. Again, this is why I use ChatGPT. I use ChatGPT to check my work. Don't use ChatGPT to do your work. You don't learn anything if you just have it do it for you, but it's great to like check your work and see if you made a mistake. Okay, complete the square, blah, 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 blah. Oh, so they divided by 45. That's okay. I'm okay with that. I can live with that. Sure. It's a hyperboloid. Right, here we go. An ellipse and a hyperbola and a hyperbola. Yep, cool. That's what we said. How to sketch, plot the center, do the cross sections. Yeah, here. Yeah, produce a 3D plot, please. Let me see what it gets. I'm curious. I'm curious if we can do this. Plotting the 3D hyperboloid. Only took it 8 seconds, apparently. It's fast. Boom, 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 boom. Boom, 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 boom. Well, it thought for 8 seconds, and now it's analyzing. Okay, here it goes. Oh, okay. Cool. Yeah, so it's got the ellipse nature in one axis, and then, yeah, it's got... Here, I'll pull this out so we can see it. They orient their axis kind of weird. Yeah, they did. This is not really weird. What? Oh, okay. Oh, actually, not too bad. Sorry. They said this was X. Oh yeah, wait. Sorry. X. Yeah. Y. They zeroed things weird. And then like this is Z. Okay, so sorry. It's really actually like this. Okay, which is kind of what we have, right? Yeah, we said it was an ellipse in, we said the y-x axis. Oh, okay. Oh, I got that wrong, maybe? No, it should be an ellipse in the YZ axis. Yeah, okay. That's what I drew here. Wait. In the YZ plane holding X constant. Yes. Okay, sorry. Yeah, this thing is going this way. Yeah. Okay, that's where this is. Yeah, it's an ellipse in the YZ axis, and then it is a hyperbola in this axis, and then it's also hyperbola in this axis. Okay, cool. Nice. Great. Good job.
Well done! Well done!
Okay, cool. Sib, I'll do yours right after this. Let me help Everett, because people from TikTok don't usually stick around very long if I don't do their question right away. It's just the nature of that app being, like, very, very swipey. Okay, I'm trying to read this. Bless you for trying to give me a clear image. It's okay. Okay. Okay, given A and C are... I can kind of read this, though, I think. I'm assuming this is C here. Yeah, you're welcome, Sib. Let me try to redraw this. Okay, so I think this is A. This is B. I believe this is C. And then they're giving us something here that goes to a point D. And then I think they're calling this angle 1. They're calling this angle 2. They're calling this angle A. And they're calling this angle B. Or angle C, sorry. Okay. Well, they do give it to me, right? I always like to just... Yeah, okay, so here's how you do proofs. I'm going to state all the givens. I probably don't need to. But if we don't need them later. So... Everett, if you ever want to, like, do proofs, and this is a good thing, you will use this in, like, logic and, like, all other classes later in life. But the thing is, Jeff, even though things are trivial, you have to with a proof, you have to kind of, like, demonstrate each step of, like, why that's true. So we're trying to prove that angle ABC is equal to 90 degrees. Okay. Angle ABC. Okay, yeah, so from here to here to here. And what we do know... Okay, so this is always, like, the statement. And then this is the reason. And you have to be kind of, like, bulletproof with, like, your reasoning. You can't just say just because, or just because it's obvious. There's certain rules that you're allowed to say, like, why something is. So what I always like to do is to put down the givens, okay? So this says angle 1 is complementary, angle 1 is congruent to angle C. So I'm going to say that. So angle 1 is congruent, or sorry, not congruent. Yeah, is congruent, yeah. Which means it's equal. And you can say this is given. And then you should always label your steps, okay? So I'm going to say angle 1 is congruent to angle C. Angle 2 is congruent to angle A. This is also given. Okay, sure. The measure of the angle. Yeah, if we want to be like, yeah, whatever. And then A and C are complementary. Okay. So we're going to say that angle A is complementary to angle C. And that's also given. You are right, Jeff. Jeff is right that technically you should say the measure of these angles are, but your teacher is just putting the angles, so whatever. Okay. And then what we're trying to prove is that ABC is equal to 90. Okay. So if I want to show that, like, ABC is equal to 90, I think it would be nice to show that angle 1 and angle 2 are complementary to each other. So I always like trying to write down the goal. The goal is that like angle 1 is complementary to angle 2, right? Because if two angles are complementary, right, they add up to 90, right? This implies that angle 1 plus angle 2 is equal to 90 degrees. Oh, that website's not working? Oh, it should be, Lynn. Why is it not working? Maybe, put the HTTPS in front. Like, if you do that. Oh, wait, that isn't working. Wait, what the hell? Wait, did you spell this right? Oh, you have to say actualdiscord.com. .com. Forgot the .com. Oh, also, yeah, don't put the HT... Whatever, just do this. I need to work on the SSL for this website. It's a mess. It's coded by myself, so it's not hosted. So just tell it that it's safe. I'm not going to take your credit card information. We're not accepting credit cards either. What problem are you doing? We're doing this. This is a geometry question, Marva. So we have this triangle here, and we're trying to prove that angle ABC is equal to 90 degrees. I do teach SAT. Yeah, I do a lot of... Yeah, if you have an SAT question, I'll do it. I'll go over it. Okay, so... I think I know what I want to do here. I think, Jeff, I want to say that, like, this is an angle and this is an angle, and they add up to 180, and then that these all must add up to 180. So then, if this is complementary to this, then this is complementary to this. That's my long-term goal is what I see. From 3, angle A plus angle C is 90 degrees. Okay, I agree with that. And then, but then how are you going to show that the other one is? Yes, yeah. I think I need to define angles ADB. Then sub A is equal to 2. Oh, they did tell us that, didn't they? Oh, they said this is equal to this, and they said this is equal to this. Yeah, exactly. This is actually not a bad proof. Okay, let's do that. Cool. I was going to try to, like, define this as being 180 degrees, and then I know triangles are 180 degrees, but they gave you this. This is actually kind of a layup, Everett, of a question. They kind of made this kind of easy. Okay, so here, statement 4. This is where we're starting to state new things, okay? I'm going to say that angle A plus angle C is equal to 90 degrees. Okay, and then what you have to say is definition of complementary angles, which you can also say sometimes you put the 3 here because you're using this statement to write this one. It is true, right? Yeah. Yeah, sorry, not with the I. Yeah, my bad. I should have saved myself and just stopped at the P so that I wouldn't, like, make that mistake. Yeah. Compliments are what I desire to have in life. Compliments are... I mean, you also desire men as well, I guess, but we're working. All right. Okay, so then what you can do is you can say that angle 1 plus angle 2 is equal to 90 degrees. And then this is by... I think this is called substitution. You can say, like, substitution. I'm from Los Angeles. And then this is from 1, 2, and then 4. So you're taking this statement, 1 is equal to C, 2 is equal to A, and then you're substituting them into this to get that 1 plus 2 is equal to 90. It is double substitution. Yeah. But it's important when writing proofs. You have to justify where that came from. Right? I'm substituting 1 and 2 into 4, and that's how I get statement 5. Nice, Lynn. I see yours. Okay. So then if 1 plus 2 are equal to 90 degrees, and then I guess this is the final thing, right? Is that angle, what do we want to prove? Angle ABC? Yeah, I could say angle ABC is equal to angle 1 plus angle 2. And I think this is, I think we call this coterminal angles. Is this by coterminal angles? I think that's the rule. No. It's by the diagram. Yeah, there's a name for it. Sorry, they're not coterminal. In a geometry proof, what do I say? That two angles add up. Oh, they share a line. Yeah. Collinear angles? Are they collinear angles? Keeps showing my Google ads. Alright, 1 second. Here we go. I'm just gonna ask ChatGPT. There's a name for this. Okay, angle addition postulate. Or adjacent angles. Okay. Interior angles. Okay. Point D is interior to ABC. Okay. I like that, Joe. Joe says interior angles is the better way to say it. No. I get what he's saying. No. That's alternate interior angles. Yeah, he's talking about this. So if you have angle ABC, then DBC plus ABD is also ABC. Do you see that? Like, D is the middle line. Yeah. So, yeah. Basically this. So this, ABD plus DBC is equal to ABC. Because D is an interior angle. Okay. Your teacher says... Okay, we can say angle addition. Yeah. The important thing in doing geometry proofs is that you're only given, like, certain rules you have to work with. So, yeah, angle addition. Okay. And so, because of this, right? Then we say that angle ABC is... angle ABC equals 90 degrees. And that's by, I don't know, substitution, maybe? Because technically 1 plus 2 is equal to 90, and this is also 1 plus 2. And so you'd say like 5 and 6. And then, I don't know, like angle ABC is a right angle. And maybe that's like a definition of a right angle. And then you could say 7, because technically you're referencing this. Okay. But yeah, that's how to do a formal geometry proof, Everett. If that makes sense. You just have to be very careful about every time you state something that you have, like, an ironclad, like, cannot be debated reason for doing it. And I know, it seems very annoying to have to basically state the obvious, but it's a useful thing to learn, especially nowadays where everyone seems to have lost the plot with logic. No, it's very useful to be able to try to state what things are. Okay, I do have to go in 10 minutes. I promised Sib I would work on hers at least, though. But cool, I hope that helped you, Everett. It makes much more sense now? Fuck yeah, dude. Yeah. Feel free, join our Discord. If you ever have other questions, you can post them in the Discord, and we'll go through them, or just stay on top of the schedule, and whenever we live stream, feel free to submit something. I'll help you out with it. Okay, let me try to do this one for Sib.
Nice.
Thanks for the follow, Skella Shit. That's a fun name. And then Lynn, I do see yours. I might not get to it today, but I will get to it first thing tomorrow if you're here. I see yours, Lynn. This is something about subspaces and subsets. This is stuff that kind of, I mean, I enjoy because I learn with you guys, but I have not explicitly gone over this, but there are other people that have, and they kind of like help me out to learn this so that I can teach it to you as well. Yeah, linear spans. This is, I would love to learn this stuff, and I'll learn it with you if we go over it. If M and N are subspaces of V, then so is M plus N. Yeah, this is where we get into like math definitions of, I think this is called like discrete. Isn't this discrete math is what we call this? Cool, you be here tomorrow? Nice. I may ask like Zach to help me out with that. He knows more about it. I think it's discrete. Oh, it's abstract algebra? Okay. Okay, let C be the oriented curve parameterized by this. Calculate C 2xy dx plus all that dy blah 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 dz going from 0 to pi. Oh, okay. Yeah, this is where they say it's just equal to the... Okay. Yes, okay. I think what you have to do here, Sib, right? You first have to prove that this is a conservative vector field. Yeah, no, Nick, yeah, I won't. I have to go in like 9 minutes. So step 1 is like prove the vector field is conservative. Because I think this is what happens. We say that if this is the integral of this dot some field f, then this is also equal to, it's like f of I don't know, 1. In this case, I think it's f of pi minus f of 0. If you can show that, and then I think how this works is like grad f is equal to f. How does this work? Yeah, because they talk about potentials here. And this falls a lot into this, where like grad v, I think, is equal to E. Yeah, I'll get you some more. Yeah, my bad, Nick. I'm sorry. Okay. So, proving that it's conservative. So we have 2xy comma x squared plus e to the y sine z comma e to the y cosine z. And then I think what I show is that like and then this is like f, or sorry, I think they use big F here, and then this is like little f. Yeah, where little f is the antiderivative of big F. So I think what you have to show is that like df dx minus df dz is equal to 0. Is that right? Wait 1 second. How to show vector field is conservative. Oh, sorry. Not E. Yeah, Z minus X. 1 sec, here we go. Okay, I almost have it. This is very similar to another one we did. Yeah, that's true. And then this is the other thing that's true. Right, so big F is the field, okay? and big F, right? Yeah, big F is equal to the grad of little f. Right, so we end up integrating this eventually, is what we do, to get little f. And then that means it's a potential, which means you can just do this. It's path independent. Okay. So you do... That's right, that's right. And these are the different components. Oh, okay. I see. So, yeah, this is actually really cool. Okay. So this is the Z component of F. So this is like dfz dy is equal to dfy dz. Oh, okay. Okay, I think I remember how this works. Okay, so then dfz dx minus dfx dz should be 0. So let's see if that's true. So the derivative of this with respect to x, oh, that's 0. Cool, and the derivative of the x component with respect to z is also 0. That works out, okay? So then also, here, I'm just going to prove it's conservative first, and then we'll continue this the next time, but this is a good first step. You always want to see if your vector field is conservative, because then this opens up a lot of possibilities to figure out, like, what a vector potential is, and then you can just, you don't care about the path anymore. Okay, so then, like, dfy dx minus dfx dy, that should also equal 0. So let's see if that's true. So the y component with respect to x, that's equal to 2x. And then the x component with respect to y is also equal to 2x. Nice. So that's also equal to 0. So then we look at, is df y dz minus dfz dy equal to 0. So the y component with respect to z, that's going to be e to the y, negative e to the y cosine z. And then the z component with respect to, oh wait, no, the derivative of sine is positive cosine. And then the derivative of this with respect to y, cool, e to the y times that is just e to the y cosine z. Wow, okay, cool. So yeah, so this, you've now proven that this vector field here is conservative, and so what you're having is, you're having the divergence. So this is div, or it's like nabla dot. This is called divergence. The divergence of this is then integrated over a contour. Is the same thing as just kind of like the fundamental theorem of calculus. You're taking like the integral of a derivative, which is then just the antiderivative at one bound versus the other bound. This is where like it like really comes from. If you have the integral of what is this, like, you know, df dx from a to b, this is the same thing as f of b minus f of a. This is called the fundamental theorem of calculus, right? So where this is like the antiderivative of that. Yeah. And that is kind of what this is, just doing it in 3 dimensions. Because now you have nabla, which is df dx, df dy, df dz. Okay. I gotta go pretty soon. But this is a cool question. Let's close that stream. Okay, cool. Thank you, everyone, for coming to Actual Education Office Hours today. Yeah, so we'll go over yours more next time. I like that. That's a cool question. Great review. Thank you again, Lynn, for your question. We'll go over yours tomorrow as well. Again, if you just found us here from YouTube, TikTok, whatever, please go like, subscribe, all that fun stuff. Helps us be nice with the algorithm. And if the algorithm's nice to us, then we can go help more people, because more people see our stuff. So please, your support is awesome. You don't have to give me any money. Just give me a follow. Grim, I gotta go right now, sorry. Okay. Anyways, okay, cool. let's go raid a channel. So if you're with us on TikTok, not TikTok, sorry, on Twitch. Grim, I really got to go in like 1 minute. 1 sec. We're gonna go raid. Fine. We're gonna go raid Phobos. I like Phobos. Raiding? Phobos. Okay, cool. Grim, I'll talk to you afterwards. But all right, I gotta go. All right, enjoy the rest of your Tuesday. We will see you on Wednesday, 5 o'clock Pacific, 6 p.m. Mountain, 7 p.m. Central, 8 p.m. Eastern. Enjoy the rest of your week. Peace.